Hi everybody. Thanks for coming and joining us in the very last session of today. Thanks Ryan for hosting us all as part of the conference. So my name is Nora. I'm a curator and based out of Ireland. I'm interested in, the creative expression around artificial intelligence and how it can call attention to the complexities of the socio-political conditions in which algorithms and computation resides within our everyday. For this panel, we're looking at machine intelligence in the context of art, and we're looking at the new types of knowledge, values and meanings that these technical modalities make possible, and how we might kind of read and understand artistic work in kind of contemporary technological conditions. So I'm joined today by three different speakers whose practices are across a broad range of subjects. And the first speaker that we have today is by Ben. Do you want me to give you a little introduction?
Sure,
Yeah.
as well.
Sure. So Ben Bogart is a Vancouver-based interdisciplinary artist working with generative computational processes involving physical modeling, chaos feedback systems, and computer vision and machine learning. And he's been inspired by knowledge in the natural sciences, including quantum physics and cognitive neuroscience. I guess that's an interesting place to maybe leave it there for your bio. And today he's going to talk about machine subjectivity.
Thank you, Nora. I forgot I had to pick up the second microphone. Hello, everybody. So I am going to be talking about the subjective machines, and part of this is supposed to be a little weird and challenging, so feel free to push back on everything. So I'm interested in subjective machines because of my work with machine learning, and I'm going to call them learning machines because I'm interested in thinking about them as objects and methods, not necessarily disciplines. Machine learning is a discipline. And so learning machines are something that I've been working on since about 2007. So they've been quite integrated in my practice. And I've been thinking about them in a particular way through exploring them in various artistic manifestations. So I think it might be worthwhile to talk a little bit about how I think about these machines that learn. And part of that is because there's just so much hype and mystification about what they can and can't do. And so I would define learning machines as any system that can improve their performance on some task autonomously. Often the conduction, the performance of the task involves some kind of statistical model. Sometimes the machine learning's purpose is only to make a statistical model. But at least in the kinds of things like deep networks we're talking about most often these days, and the leaps and bounds these technical systems are reaching, those are almost always exclusively being conducted by a statistically oriented machine learning system. So I want to really enunciate and emphasize that the kinds of models constructed by learning machines are the same kinds of models that human statisticians would make. There's nothing miraculous about learning machines. They are not magic. They are not necessarily the future, but they could be. So why are they special if they're just more statistical models of which we have no shortage? I think of kind of two poles. One is a pro and the other one's a con. The pro, and the real reason why they're so popular and we're talking about them so much, is the degree to which they're scalable. We can make really, really big statistical models trained on lots and lots and lots of data now, and we can do it in a way that's much more cost effective than it would have been had we done it with human statisticians, even those using computers. So the big part of why things are so popular is that it's cost effective. It has a value in a capitalist system to autonomize even statistics. But the con is to what degree they are actually interrogable. And by that I mean, how much can we question their results? How can we have a conversation with them about why they have made a statistical conclusion? And they're not very good at that, especially the deep networks we're talking about most often when we talk about machine learning today. So they're really black boxes that are opaque and invisible. And as they're deployed in all kinds of contexts through social media and marketing systems, in a capitalist context, we have to be really careful about what they could be saying about us in terms of the models they're building. And so for me, one really big question is, how do we validate these models if the only cost-effective way to produce them is by building another giant machine learning system that does the same thing? If we can only compare them to each other because we can't compare them to a model constructed by a human, how do we know they got it right, especially when we can't interrogate it? So that's my entry point for subjective machines. It's kind of pushing against this idea of the objectivity of the statistical model in the context of autonomous machine learning systems. So I'm not going to define, well, I am going to define subjectivity, but I'm going to define it in a very narrow way that comes out of my practice in thinking about learning machines. So a subjective machine, the idea of subjective machines is a framework for thinking about objectivity and subjectivity, both in autonomous machines and also in brains that are in biological material. And this kind of follows from my PhD work, which was funded by the Social Science and Research Council of Canada on making a machine dream. And you can ask me more about that later. I'm not going to talk about it. So I'm going to get the definition out of the way right away and then talk more about details. But I define subjectivity as an interaction between sensation and imagination that forms a reinforcing pattern resulting in perception. Simple enough. There are two philosophical assumptions behind this definition of subjectivity. There's probably more, but these are two that I'm picking out. And these ones are really important to me because they're my own personal beliefs also. The first is that the world independent of cognition, that is the world that we cannot conceive of, that is beyond senses and perception, is actually there, but it is unevenly distributed and continuous. It's not made up of discrete chunks of things, although some physicists would disagree. And second is, following from Merleau-Ponty, this idea that you can't have a concept of what a subject is without already having a concept of what an object is. That the idea of point of view and experience infers a relationship between two different sides, a thing to be perceived, but also a perceiver who is able to extract that thing from its world and think about it as something independent. So if subjectivity is this interaction between sensation and imagination, what do I actually mean by imagination? I think imagination is the ability to construct things that aren't a mirror of the outside world. So one way of thinking about that could be novelty generation. But I would define it as a cognitive process that facilitates the generation of internal subjective representations, in particular including mental images. So what is sensation? Sensation allows information from the world as independent of cognition, that thing outside of us, to implement those same subjective representations. So what's the relationship between sensation, imagination, and a machine? So those definitions of subjectivity definitely apply, at least in my thinking, to biological agents. But maybe the idea of machine imagination is a little less clear. And so I would define machine sensation, for example, as the representational information patterns that are fed to a computer, and they're often called the training data or a corpus of information, a body of information. And those are most often measurements of something. It could be atmospheric measurements or an image from a live camera or almost anything. The flip side of that is imagination. And I think of the imagination of a machine as being implemented by unsupervised machine learning algorithms. So I'm not going to get into what that means very specifically beyond saying an unsupervised machine learning algorithm is like a classifier. It decides that in this space of measurements, which things belong to cats, which things belong to dogs, which things are associated with maleness, which things are associated with femaleness. And I think of that classification problem as the projection of boundaries into that underlying continuity that is independent of cognition. So here we have a whole bunch of points. This is about 10,000 individuals. The x-axis, I believe, is height. The y-axis is weight, but I could have gotten those flipped. Doesn't really matter for the purposes of what we're going to talk about. And this is classified or labeled data. So the white dots mean one thing, and the black dots mean something else. So we might guess that since we're talking about body mass, that there could be a gender thing going on here. We can see that the images at the very top here, there it is. Above a certain point, there are mostly white lines. Below a certain point, there's mostly black points. And then the same thing for the extremes on the other axis. And so sure enough, if we plot the means, which are very hard to see, but that is the mean of the black dots, and that's the mean of the white dots, we can say that yes, on average, men tend to be taller and heavier than women who tend to be smaller. I'm bringing this up because, as we can see, this data is very, very messy. And this idea that there are two categories, men and women, as separable by some property, as in body mass, means that there's a lot of things that are lost. There are a lot of women that are really, really exceptional. And then there are a few men that are extremely exceptional. And so what's important to me here is this thinking about that underlying continuity, that when we're measuring the world, less biased, measurement always includes some bias, but less biased by cognition, that there's a lot going on. The classification problem, the deciding which are men and which are women, involves projecting these imaginary boundaries. And my argument is that those boundaries are fully imaginary because they can have multiple positions. We could draw a straight line that bisects the two means, or we could invent something really bizarre. And I would say a lot of the kinds of knowledge conceptual representations that are generated by machine learning algorithms these days probably look a lot more like this than they do a straight line. So the question of arbitrariness and kind of generative processes and imagination is always implicit at the very bottom level of these systems. So I say these are imaginary because there's no single objective solution for dividing those two spaces, that they're conflated. They are continuous in their essence in an underlying fashion. Different similarity methods and different algorithms would draw different kinds of lines, and that really changes how people fit into those categories. These boundaries that define groups allow us to group sensory information into different camps. So we can think of a kind of proto-concept, or in the case of my work, I call them percepts, very low-level abstractions of sensory information that refer to a category, for example, male or female. And so the contents of subjectivity emerge from this interaction between the underlying data itself, that there is a distribution, there are measurements that can be made of something independent of us, but there's always necessarily this act of projecting imaginary boundaries onto that continuity. And so I would say subjectivity is this emergent interaction between those two forces, between what the world as independent of us imposes upon us and what our processes of imagination impose upon that external world independent of us. So to summarize, the basis of subjectivity, and also I would say also the basis of all of cognition, is perceiving two different sensory patterns as belonging to the same imaginary class. It's seeing two leaves and just thinking they're a leaf, and not attending to the uniqueness and individually measurable properties of each. Every moment in time is a unique moment. We can only make sense of anything by grouping things by similarity. So what is the point of this? I think it's a useful way of breaking down the kind of magic around a machine learning system just being a big black box of objective knowledge, because it allows us to poke it in certain ways to see what are the different components that are actually informing the kinds of knowledge or the kinds of models that they're actually producing. And not only that, we can also use this kind of framework for thinking about both our machines and ourselves in a way of interrogating our own bias and prejudice around the imaginary concepts that really constitute our lived experience. So we can ask very specific questions of the black box. How sensation is represented? How are we measuring these points? What is preserved and what is removed? How do those people who are on the wrong side of the line fit into the model or not? What are the similarity measures being used? How are we comparing apples and oranges? And whether those ways of comparing things are actually valid culturally or not. And of course, finally, the summation of all those things is where the boundaries between classes in this continuous space that is beyond our comprehension, where they actually end up. How much time do I have? Perfect. I can go through this really slow and easy then. So watching and dreaming is my current body of work, and I'm taking the kinds of learning machines that I had been using in previous work, except I'm applying them to the appropriation of popular cinematic depictions of artificial intelligence. And right now I'm working with Blade Runner, 1982, the original, 2001: A Space Odyssey, and Tron, which are all 80s movies that kind of cue some kind of science fiction future, but are also a time where artificial intelligence kind of started growing in it was one of these early humps of growth of machine intelligence. So in this appropriation system, the original film itself, both the frames and the sounds, are the machine sensation. So the world perceived by the machine is the world of a film. So the title of the work is Watching and Dreaming. The dreaming more refers to my PhD work, and I'm not going to talk about that too much. And this is kind of a false dichotomy between watching and dreaming, because the argument of my entire PhD is that watching and dreaming are continuous. It's one system of simulating mental images. So watching is more an emphasis on how sensory information allows the construction of mental images through these subjective processes. And that is how we make sense of the world. That is our own kind of perceptual system, but it's also how the machine makes sense of 2001: A Space Odyssey, for example. Dreaming is a little more complicated, but we can think about it as relating to time. So dreaming is more about the occurrence of events over time rather than the kind of construction of a individual moment in time based on sensory information. But again, that's a false dichotomy. So watching 2001: A Space Odyssey was very recently completed. Its first exhibition will be as part of a triptych of works showing versions for Tron and Blade Runner at the Surrey Art Gallery in April. And so I'm just going to step through a concrete visual example of this process of subjectivity. So this is an original frame from 2001: A Space Odyssey, where we see Hal, who's highlighted by the light in the panel. He's a disembodied robot with a camera that can see around. And he's playing chess, which is a nice proxy for how we used to think about machine intelligence. Playing games must be the ultimate of machine intelligence because it's hard for us. Seeing, being embodied, using objects, that must be easy because they're easy for us. But it's totally flipped in the other direction. And he's playing chess with somebody he kills in the film. Sorry, spoilers. So what does it mean to project boundaries in this continuous space? So we know that that original frame is unevenly continuous, meaning some parts have more color, other parts don't. There's different kinds of densities. There's all kinds of things happening. But to make the machine make sense of it, we have to break it into pieces. And that is this imposition, this imaginary projection of lines and boundaries in that continuous space. So this is a depiction where each colored region is one piece that is bounded by these imaginary projections. Once you do that, you can extract each of the pieces within those boundaries, and these are all of the components from that first frame. And you do this, or I do this, for every single frame in the entire movie, which results in 47 million little image pieces. So one thing about the fact that there's 47 million image pieces is that's just a massive amount of data. So in my case, there's actually two layers of subjective imaginary construction. First, there's this projection of boundaries into the continuity to construct these things. Then the second level is to project boundaries in the space of all of these things in order to reduce what is perceived as redundancy. So we can see some of these are all very similar to each other. So you could imagine to reduce the amount of information, we could just group all those together, and by grouping them, we're constructing these percepts, which are again a function of making boundaries between things that are similar and things that are different. And so once you group all those together, I used an algorithm that averages all of the ones associated with each percept. So all of those purple squares get averaged to one kind of image. All the red things will get averaged to something else. And one component of this project is to make large-scale collages that are intended to be 48 by 48 inch light boxes. So we can't quite get a good sense of, oh no, this is horribly low resolution. They are about 15,000 pixels wide and the same size as they were in the original film. So this is these percepts. They're the higher level abstractions of that sensory information, but they are the 5,000 largest, and that 5,000 largest tend to be the ones that are the most unusual. They're the furthest away from the others. And that's why they have such hard edges. So these really bright colors in these corners and the really large framed sizes, like over here, are all because those are ones that weren't easily grouped into categories. So those are those exceptional men and women that don't fit very closely in their own classes. They're kind of out on the edges of things. And so if I use this vocabulary, that's the visual vocabulary of the system, watching is this process of constructing this mental image that is how the machine, we can imagine the machine sees that first frame, where each of the pieces extracted from the original are actually represented by their nearest percept. That is the higher level abstract representation that is most similar in terms of its features to that lower level piece. And you end up with something that resembles the first frame, but is also dissimilar from it. And it's somewhere between, and each of these can approach like a Gaussian distribution where the edges become really soft because there might be a lot of individual components associated with each of them. So I'm going to finish with just a little statement. And by talking about machine subjectivity, my hope really is that we can all consider the degree to which both our machines and our own mental processes are biased and not representations of reality, but really imaginary, creative constructions in our minds. They just happen to be synchronized by the fact that we live in the same world. So we have that same underlying sensory information. And so maybe we should be considering the validity of all concepts in terms of this idea of a subjective point of view. A subjective point of view being a particular combination of similarity measures, that is, deciding things are similar or different, abstract representations of things constructed from those similarities and differences, the contents of boundaries that are projected imaginarily, and also that underlying information distribution, that thing that is independent of cognition, the actual numbers that informs that whole system. And I think by thinking about all these things in the context of machines and ourselves, maybe we can get better at understanding diversity and the idea of where mean fits in with validity of statistical models and also just computational ways of knowing the world.
Thank you. That was very interesting. Next up, we have Sofian Audrey. Is that the correct pronunciation? Yes. Okay. He creates artistic works through different forms such as robotics, electronics, interventions, interactive installations, and net art. He holds a bachelor's degree in computer science, an MSc in computer science from the University of Montreal, and he's currently an assistant professor of new media in the School of Computing and Information Science in the University of Maine. He's going to talk to us a little bit about what we turn the machine's attention towards.
Bonjour tout le monde. Je suis vraiment privilégiée d'être ici avec avec vous et avec Ben et Allison. C'est vraiment une belle opportunité. Merci beaucoup aux organisateurs de Art Engine d'avoir permis cet événement d'exister. Hi everyone, thanks for being here. I'm really privileged to be here with Ben and Allison to discuss these questions that are just always flowing through my brain. And thanks for the organizers at Art Engine for the invitation. So in my work, I'm interested in hijacking and subverting computer science and AI technologies and sort of use them to reveal some aspects of, in the end, I guess, of what makes us human. Most technologies are designed to be powerful, to control, like Suzanne mentioned earlier, to enslave. I really like that idea, to enslave nature, to enslave us all. And to at the same time to maybe solve some of our problems, to cope up with our deficiencies and our imperfections. But in my work, I'm interested in flipping that and revealing these very imperfections that I think makes us what we are. And I think that these things can be found in these technologies that we design. So most of my work revolves around these notions of agent and behavior. Agents being, sort of coming from this computer science notion of agent-based model that comes from cybernetics. An agent being an entity that acts in the world in response to observations. And the behavior being like how another entity would perceive this agent, so as an unchanging form of events due to the activity within an assembly. This comes from Gordon Pask. Pask has a very broad notion of what an assembly is. He talks about the behavior of a statue. So I would personally, I would argue on that, but so I would personally replace the word assembly with agent. But I'm interested in how we experience these behaviors and how they can be used to generate new experiences. So this is an example of a work, one of the first actually works where I started using machine learning in 2011. It is a robot that was hanging to a cliff in the Catalonian Pyrenees, and this robot is looking at the cliff right now because it doesn't like sun. It doesn't like to see the light, but at the same time it needs the light because it needs to recharge its batteries with the solar panels. So it needs to, once in a while look at the light. And I gave it I used a reinforcement learning system where to let this agent try to solve this conundrum over the summer. So I'm going to throw a few concepts here just to get the conversation ready. But I mean, like Ben already introduced machine learning, but I'm just going to give like what I think what for me is a very good summary of to try to understand what machine learning is in comparison to artificial intelligence, which is so machine learning is a subfield of artificial intelligence, and artificial intelligence being this big project of trying to reproduce human performance in all kinds of spheres. And the problem is the following: how can we get how can we program machines to do things we do when we ourselves do not know how we do these things? And this is almost everything. When we talk, when we walk, when we make decisions, most of the time we use our intuitions. We do these things without even thinking about them. So if we don't know how we do them, how could we even program them into a machine? And the intuition here from machine at the base of machine learning is, well, we don't know how we do these things, but what we know is that we once did not know how to do these things, and we learn how to do them by subjecting ourselves to experience and by adapting. So that's the approach that machine learning brings, is like, let's create programs that can learn by themselves by looking at experience and observing the world. And this comes from, the first idea comes from the I would say, from this 1950s early cybernetics notion of feedback. So where a system makes a decision and regulates itself, makes small adjustments based on the results. Now, machine learning has, again, taken that very interesting idea of an agent adapting to the real world. And once again, I'm going to reuse I really like this concept of that Susan was talking about earlier of enslavement. So machine learning has enslaved these little agents into doing something where the agency of the agent doesn't matter anymore. What we're after is to solve a problem. So using a model, we train an agent on some data, and we try to adjust it, make it adjust itself to solve whatever problem we have, whether it's going to be like speech recognition or recognizing faces or making as much money as possible in the stock market. So this is a project I'm working right now where I'm following kind of this similar idea. I'm trying to unfold this process that of learning. So I mean, like nowadays, if you look at machine learning algorithms, we use them every day. We don't necessarily need to know how they work. But I think that for me, what's interesting is how they work, how they do this learning, because I think there are some very interesting. I see that there's a potential there in looking at the system learning. There's a potential for revealing, again, some things about ourselves. So this is a project I'm working on right now called Morphosis with Rosalie Dumont-Gagné. And Rosalie is a visual artist really interested in artificial life and embodiment. And so we're working on this kind of ball robot that will have a strange, non-continuous body, and we'll have to try to learn how to roll. We're still far away from that, but getting there slowly. Another project I've been working on last year is I started working with deep learning and training on text. So I've never read that book. It's a book by, sorry, that's my book, but I've never read the book Wuthering Heights because I'm French, and that was not the kind of, that we didn't read these kinds of classics at school. We read the French classics. So anyway, I thought like I'd train a neural network to read it for me because it looked like an interesting book. And what I was interested, I mean, there's a lot of like stuff like that exists where you generate systems that will you train systems on text, and then they'll be generating these kind of weird literature. But what I'm interested in here is in unfolding again this learning process. So looking at all the little steps through which the agent goes when it's learning. And this has given 2 projects right now. One of them is an art book. So it's a series of 31 unique books that retrace this kind of learning process. And another project is called Of the Soon. This is a project with Erin G. Erin G is an artist, a sound artist, new media artist who works with putting human voices in artificial bodies and artificial voices in human bodies. So we were interested in this technique called ASMR, which stands for Autonomous Sensory Meridian Response, which is, you can look it up online. There's tons of videos of people doing weird shit that are the intention is that to create, these kinds of tingles that you can have when some people react to different kinds of things. Often it's like very high-pitched sounds like whispers or personal attention. You'll see people working with all kinds of different ways to generate these states of getting these tingles. And anyway, and we thought that it would be interesting to revoice this text generated by an agent reading a book by a dead person and revoicing it to create try to create this bodily phenomena. So anyway, just play an excerpt and maybe we'll see if you get the tingles. Playing. So I don't know if you could hear this kind of progress where, so this is an example. This is really from the beginning of the composition of that text where initially the agent is completely random, so it doesn't really know anything. And then as it proceeds to read the book, it learns some rules about combining elements. So of course, at first it gets crazy about spaces because it just sees there's a lot of spaces in that book. And then eventually it becomes more and more structured and starts creating more themes that are longer. And eventually it's able to compose words and full sentences. So another, which brings me to this next aspect that I'm interested in, which is, I think is relevant to this discussion, is the question of indeterminacy, autonomy, and command. So, one of the work that Chris Salter was mentioning earlier that I've worked on, where I started to work with these questions of using machine learning for art making, for generating different kinds of behaviors that would feel like something recognizable, but yet always lying beyond our grasp. And in Polytope, we were investigating, trying to start with the question of how would Janez Zenekes, who created in 1967 and then in the 1980s a series of work called the Polytopes, with these kind of like movements of light and sound and these kind of total spectacles, and we started from this question: what would Zenekes? How would Zenekes have worked? How would he have made such works if he had access to the kind of technologies we had today? This is another work, Vessels, in collaboration with Stephen Kelly and Samuel Saint-Aubin, where we created these small groups of robots that are autonomous and that just communicate with one another and move on beds of water. We've shown that outside in the outdoors in like public spaces, and the idea that like these robots are sort of evolving together, a kind of a group behavior, and how could we use that as a way to induce different kinds of ways that people are projecting themselves on the robots, and so when I look at this work, what I find the most interesting is to look at how people interact with one another when they're looking at the robots and moving around the space. Which leads me to the second principle of machine learning as we know it today, which is self-organization. The idea that like you have all these independent units that are working together to create these layers of emergent representations. This is an example that I really like I think is really telling. In the mid-1990s, Adrian Thompson, I think his name was working on evolvable circuits. So he designed this system with these circuits they were called programmable field arrays or something like FGPAs. And basically these, he tried to solve a very simple problem where in the input you would send a sound wave, and in the output there should be a signal, let's say, 5 volts if the input signal is 1 kilohertz and 0 volts if it's 10 kilohertz, something like that. So just like make a classifier using a circuit. And he used a genetic algorithm approach where he tried different kinds of circuits, took the best ones, and then made modifications on them, sort of have them mix them together, and then go to the next step. So it is an iterative machine learning sort of approach. And in the end, he got a circuit. And what he did is that, like what is traditionally done, I guess, in that field, is that he removed all the parts that did not matter. that were disconnected from the rest. And after removing them, he realized it didn't work anymore. And then he realized that actually some of the parts in the array needed to stay there even if they were not logically connected to the rest, because the circuit somehow was using the small little interferences in the circuit to achieve its goal. So I think that, to me, this is a very interesting example, because what it tells me, what I think we can get from that is that adaptive behaviors or machine learning systems, it's kind of a metaphor, I guess, that we cannot really understand them rationally. They're like, it's related to what Ben was saying about deep learning. We can't really, they're hard to analyze. We can really, it's very difficult to, because they're not rule-based. They're not based on specific rules. They're based on an adaptation of a body. And I think that what I speculate is that then if we generate behaviors with learning machines, we cannot, and I've with the experience I have with audiences that are looking at these systems, they're often like, if they stay long enough, so if they don't stay long enough, they usually don't find it interesting. But if they stay long enough, they get to know them, and then they're able to start making inferences, and then it becomes more telling for them. So and I think that the reason is that again, because they cannot be explained by saying, oh, this is what's happening, you know, A causes B, which causes C. They can only be known in a phenomenological manner. So how do we deal with indeterminacy, common versus autonomy? I'm just saying, like, I think this is a thing that is coming very often in when you work with such emergent or self-organizing machine learning systems, is the tension between command and autonomy. So as an artist, you have certain intentions. You want to make something, so you want to keep control over things. And this is a bit the Xenakis voices comes, and Xenakis was using these indeterminate systems. He was saying, you know, I'm the ultimate arbiter of these processes. And because kind of the opposite view, and I guess I'm closer to that other view, which comes from John Cage, who says, well, let sounds be themselves, let things be themselves. So let's just put some things out there, leave these things to be autonomous. It might be good, it might be bad. I don't care. What's important is there needs to be this, these autonomous processes have the potential to bring certain degrees of surprises, uncanny feelings that I'm interested in. I will just finish with that, just talking a bit about representation, which is the third principle of deep learning. So deep learning starts from these feedback system, connectionist, self-organizing systems, but adds another level by saying, like, but by actually finding ways to move through different layers of representation, from very simple. So if you train a neural network on faces, for example, I think this is kind of an example of a convolutional neural net. In the lower layers, you'll find edges, like this automatically found, like very simple constructs. And as we move higher and higher in the hierarchies, you get more and more higher level abstractions that get reinforced. So I guess, am I out of time? Yeah, okay. So I will just show very quickly some crazy images to get your attention. Just very quickly, this is a new project I'm working on where with Tez, and we are trying to get to create this loop of this feedback loop between living organisms called Euglena gracilis, which are kind of photosynthetic microorganism that can move towards the light, and you can see that to the naked eye. If you project light on them, they will assemble in a way that I think evokes a certain form of self-organizing perception. And then these images are sent into an autoencoder, which is a kind of neural network that we twist in a way that like this autoencoder is going to look at an image and try to imagine another image that would look like a digit, like from 0 to 9, but a handwritten digit. But because the input is maybe not is noisy, it will actually come up with something strange and new. And this is an example here in the corner on the left and up corner. And this is another, so kind of weird glyphs that are not really digits, but are maybe examples of the kind of patterns imagined by this collaborative system between microorganisms, neural networks, and humans who are actually at the source of the database it was used to train on. So, thank you.
Thank you very much. So last up is our speaker, Allison Parish. She's a computer programmer, a poet, educator, and game designer whose teaching and practices addresses the unusual phenomena that blossom when language and computers meet, with a focus on artificial intelligence and computational creativity. She's a teacher at NYU Interactive Telecommunications program, where she earned her master's degree in 2008. She was also named Best Maker of Poetry Bots by the Village Voice in 2016, and she's been published, her computer-generated poetry has been published in Ninth Letter and Vetch. And you're going to talk to us today about computer-generated poetry.
Something like that.
Here, you could just...
No, I got it. Okay, so hi everyone. I have my notes on my phone, and I realized only when I was sitting up here that I don't have enough hands to operate all of these things at once. So let me see if I can. That's almost good, right? Maybe if I turn that upside down.
Yeah, if you want me to just click, you can signal me to click.
No, I can do it.
All right.
Okay, I can successfully move forward in my slides and backwards. Look at that. I'm like a cyborg. Hello everyone. I'm Allison Parish. I'm a poet, a programmer, and game designer. I am a professor at the Interactive Telecommunications program at New York University, where I teach a class called Reading and Writing Electronic Text, which is a class about computer-generated poetry and learning how to program in Python. My most recent project that sort of illustrates the kind of work that I do is this book of poetry that was just released by Counterpath just last month. It's called Articulations, and I've included a sample of the output here. This book started out as an exploration of the idea of similarity in poetry. Actually, hearing Ben discuss this project, I realized that there's actually a lot of similarities between this project and his. So started out with the idea of similarity in poetry and how similarity, whether phonetic, syntactic, or semantic, contributes to our sense of poeticness and cohesion in a text. The poetry is constructed from a corpus of several million lines of poetry that I extracted from Project Gutenberg, which is a database of thousands of texts that are in the public domain. And then I used a phonetic dictionary called the CMU Pronouncing Dictionary to create a computational model of phonetic similarity that predicted a vector, or like a sequence of numbers, like a point in space, for each line of poetry. Then those vectors had the property where two lines that sounded similar to each other are closer. The vectors are more similar if the lines of poetry sound similar to each other. So the composition itself is accomplished by doing a random walk through that space. Essentially, it starts with a randomly selected line of poetry and then finds the line of poetry that is most phonetically similar to that, and then adds that to the output, and then finds the line of poetry that's most similar to that and adds it to the output, and so forth, until it's produced like, you know, a book of poetry, and it excludes any line that's previously been in there. The end result is a kind of poetry where cohesion is achieved only through phonetic similarity. That's the only organizing principle of this text, is that the lines sound similar to each other. It's weird and it's a lot of fun to read, so I thought I might, since I am a poet, I should read some poetry. The other artists here today have the benefit of being able to show videos of their work that sort of like, you know, express what they're about, but I feel like just seeing this on the screen, you don't really understand what it's like, so I'm gonna read it. Sweet hour of prayer, it was the hour of prayers. In the hour of parting, hour of meeting, hour of parting, this with power avenging. His towering wings, his power enhancing in his power, thus the blithe powers about the flowers, chirp about the flowers, a power of butterfly must be with a purple flower, might be the purple flowers it bore. The petals of her purple flowers where the purple aster flowered, here's the purple aster of the purple aster, there's lives a purpose stern. A sterner purpose fills, turns up so pert and funny of motor trucks and vans, and after kissed a stone, an ode after Easter. An iron laughter stirred, O wanderer turn, O wanderer return, O wanderer stay, O wanderer near, been a wanderer. I wander away, and then I wander away, and thence we wander away, and then we would wander away, oh why, and for what are we waiting, oh why, and for what are we waiting, why then, and for what are we waiting? A little excerpt of how that feels, thank you. Articulations is a part of a series of computer-generated books released by Counterpath. Whoops, let me come back. This is a mess. Released by Counterpath, and the series is called Using Electricity, and it's named after a line in Allison Noel's House of Dust, which is a early important work of computer poetry. The series is edited by Nick Montfort, who also showed up in Sofian's slides. And Nick's book was also released as a book in this series. That's Nick's books there. It's called The True List. These books just came out, and we did a little tour of the Northeast United States together, along with Rafael Perez y Perez, whose book was also released in the series recently. Nick's book is also a book of computer-generated poetry. In this case, it uses a small data set and a deterministic algorithm to generate a sequence of English compound words like Waterfield, Moonhill, Ringsack, Windman. I urge you to seek out this book and recordings of Nick reading it, because it's really remarkable and entertaining, and it makes your brain do interesting things. On tour, when he's introducing this book, he would talk about the word true, because the book is called The True List. And he points out that this word means not necessarily factual, but the opposite, or not necessarily the factual in the sense of the opposite of false, but in the sense of conforming to a pattern, or in the sense of the verb to true, which means to straighten or to align or to make even with something, like when you true a painting that's hanging on the wall, or you true the spokes of a bicycle wheel. This is going to get weird. I might have to. It's feeling good so far. This weird thing that I'm doing. Maybe I'll try it this way now. No, that's not going to work here. Thank you. No, we're good. We're on the right side now. Okay. So simultaneously, I've been rereading the book Ted Berrigan's book, The Sonnets, which is this really amazing book of poems composed with a cut-up process, similar to the one used by Burroughs and Brian Geisen. This is maybe my favorite book of poetry of all time. I should have included an excerpt of it here. But that book is from 1964. Berrigan was sort of working in the same era as Cage and the Fluxus and all of the stuff happening in that scene. And this is a quote from the introduction to the book. Alice Notley wrote this introduction, and I'm just going to read this. For Cage, the application of a method results in a work or a performance that's serene and free, or rather liberated as Cage, is a serious Zen Buddhist, and his work is permeated with Buddhist thought. For Ted, it more results in one that's deeply true. An aleatory method used with seriousness and respect puts one in touch with hidden powers and truths within oneself and becomes revelatory, hopefully in a way that might be relevant to anyone. Yet by giving oneself up to chance, an artist does not lose his or her originality. As Marcel Duchamp said, your chance is not the same as mine, just as your throw of the dice will rarely be the same as mine. And that was really interesting to me. Next slide, please. So I take it as axiomatic that cut-up procedures are a kind of computational procedure. Even if Ted Berrigan wasn't working with a computer, it's still essentially a computational process to take a text and cut it up and randomly arrange its components or other techniques for rearranging a text. But that formulation that it was enabling Ted Berrigan to do something that was more true, that really struck me. And it sort of helped me put this question to my research. Can computers help us write poetry that is true? And true, again, in that sense, not of like being the opposite of false, being factual, but instead poetry that is firm and that's fundamental, that expresses something that is true, right? Next slide, please. Of course, most people don't think of computer-generated poetry in these terms, right? Usually the idea of computer-generated poetry is framed like this, where that narrative of the labor of artificial intelligence, where any AI task is essentially just trying to take over the labor of a person, and the idea that, you know, human expression will be superseded by cold robotic precision eventually, and we just have to go along with it. We're helpless to resist, right? And that relies on this idea that you can formulate the composition of poetry as a task that boils down to just like a list of instructions, which you can, with research, be reproduced with perfect fidelity. And if you look at a lot of the academic research that's happening in artificial intelligence and computational creativity right now, it's all based around this idea of how can we specifically create poetry that tricks people into thinking that it was written by human beings in a typical way, like even reifying the difference between human and machine authorship, which I don't actually think exists, and hopefully you'll see that by the time I'm finished speaking. But that idea that the purpose of using artificial intelligence in art is to recreate with as much fidelity as possible things that are produced by humans without aid of those techniques, I think is like extremely boring. Like it's the worst possible thing to do with this technology. Next slide, please. When I'm making poetry with a computer, I'm actually thinking about this line of argumentation that was, you know, it's been articulated by many people in many different ways. But Victor Shklovsky in 1916 in that wonderful old saw, which I can get to somehow in my notes, Art is Device. He says the purpose of art is to impart sensation to an object as something seen rather than merely recognized. The device of art is the device of estrangement of things and the device of defacilitated form, enhancing the difficulty and duration of perception. So the perceptual process in art is an end in itself and should be prolonged. Give me the next one there, Ben. Thank you. And then talking specifically about poetry, he says, in studying poetic speech in its phonetic and lexical structure, as well as in the characteristic thought structures compounded from the words, we find material obviously created to remove the automatism of perception. Right? So in other words, the goal of poetry is to make language unfamiliar by making language unexpected. Next slide, please. So Tristan Tzara, who was a Dadaist, writing about the same time as Shklovsky actually, had like sort of like the prototypical idea of how to make language unfamiliar. This I think is like one of the earliest examples of a computer-generated poem, even though again it's not generated by a computer. It's just a procedure that is sort of computational in nature. And in this technique, the poem is composed not by arranging words, by intention in the way that we usually associate it with poetry, especially like the romantic poets like, you know, Wordsworth or whatever. Instead, the poem is composed from a source material that's taken from the surrounding environment, like a newspaper in this case, and then arranged according to a procedure, and that procedure is to select a word at random and add it to the end of the poem, and then remove that from the pool of potential words. And with this procedure, you're very likely to end up with an arrangement of words that's never before been seen in recorded history, right? And it's nonsense, but it's nonsense that is a result of a process that can be understood, right? Now there's one line from this that I think is important. We can go over like what exactly he says in here. Take a newspaper, take a pair of scissors, choose an article as long as the poem that you want to make, cut out the article, cut out each of the words, blah, 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 copy conscientiously. The last point there, I think, is this like, very typical like masculine, sarcastic distancing from the amazing thing that you just did. Like, oh, I invented this process and it's really cool, but now I have to like stand back from it and say that I'm actually better than it. But it's that line right before that that I think is most interesting. Can you give me the next slide there, please, Ben? Oops. The poem will resemble you, right? And note that Zara didn't say the poem will resemble the reader, right? He's not just talking about apophenia here. He's not just like talking about the idea of picking out patterns and randomness. He's talking to you, the writer, like it was how to write a Dadaist poem. He's talking to the person who's following that tutorial, right? The poem made with this procedure will resemble you, the writer. And I keep thinking about this line, and for me, it succinctly and presciently addresses algorithmic bias, like the idea that if you take the world and cut it up and decide how that cut up process will proceed and how the world will fit back together, it's about you. And I talked to Nick Montfort about this, and he, I don't know, we can all talk about this here. I don't know if these two would also think that their work resembles them, that it's saying something about them as individuals, but I think it's very clear that it is. Like all of these decisions that all of us are making with these techniques are about our own aesthetics at some point, and about our own lives. Next slide there. Oh, you're already there. Oh, wow. We're having some machine learning happening up here, right? Distributed cognition, yeah. This is Jackson Maclow, a quote from Jackson Maclow, who is also a contemporary of Cage, and who also worked with techniques using randomness and chance and procedure. And I think this quote sort of sums up how like the sort of the mental progression, even for me, in making the kind of work that I make, and how it moves from this idea of like, well, what I'm trying to do is I'm just trying to like expose like the underlying structure of something that I'm trying to remove the ego of the artist from the process, right? But Jackson Maclow says the motive for the use of chance, means, etc., was to be able to generate a series of dharmas relatively uncontaminated by the composer's ego. It was such a relief to stop making artworks that carry the burden of expression. But, he says, I do allow my own emotions to influence my systematically generated work. My choices of means, materials, etc. can't help being influenced by emotions, and I'd be foolish if I thought they weren't, right? And from this, what I'm realizing and what I take away and what I've been concentrating on almost in my own work is that computer-generated poetry isn't about automating the work of the poet, but instead amplifying that work and letting it accomplish things that would otherwise be difficult or impossible to accomplish.
Too fast?
No, that was good. I was talking about the idea of nonsense before, and nonsense is like usually something that has like a negative connotation. Like we don't like nonsense. It's something that we would prefer to avoid. But nonsense at some point is like sort of the point of poetry. It's like we're trying to make language that's unexpected, language that has never been heard before. People resist it, but poetry is about making language unfamiliar, and language that's unfamiliar is difficult and frightening. And sort of the role of the poet, in my view, is to make nonsense that follows systems that people can be led into by the hand so that they can undergo these processes that use their sense of how to understand language in ways that open up their minds to different ways for reality to work. I think this is like, yeah, this is the last slide. So I'm just eyeing you out of, okay, all right. I can't tell if she's being impatient with me or not. No. So I haven't like focused a lot on like the specifics of any machine learning stuff in this talk. That's because for me, I don't really see artificial intelligence and machine learning as being categorically different from the perspective of the artist from techniques that just have to do with chance or procedure. Like to me, it seems to stem directly from that, and a lot of the same artistic moves and rhetorical moves that you can make with those other previously used and still frequently used types of work, types of algorithmic work, are very similar to the ones that can be done with machine learning specifically. But the things that you can do with a computer that Tristan Tzara couldn't do with a pair of scissors and a newspaper have to do with data and scale. Like I can make work that, whereas if Tristan Tzara wanted to make a cut-up of like a newspaper, that was fine. If you wanted to make a cut-up of every newspaper, he wouldn't be able to do that because of the labor involved, right? But I, as a poet, can make a cut-up of like every newspaper. I can find a corpus of like, every newspaper ever published or something close to that, and then use that cut-up technique on that, and then see how that's different, like what's added to it by that. The other difference is scale, which goes along with that. Like I can do things very quickly with a lot of data. And those are the things I think that really open up the possibilities for artists working with these potentials. And machine learning is really just a way of like sort of managing that scale. Yeah, so when I'm talking about my own work, I see it directly as an extension of the kind of work that Jackson Maclow and Tristan Tzara and Ted Berrigan were doing with chance procedures, coming up with new ways to compose language using procedure and chance. And then I have my social media info on that slide. So that's it.
Okay. Thank you all for 3 really very interesting presentations. Sorry, I've been taking notes while you've been talking. I'm not just like on Facebook or on Twitter. Yeah, so it's interesting though to see as well, just there's a lot of correlation between all of your practices in terms of like how you're thinking about procedures and processes and the types of things that actually machines actually open up. One of the other things I was really quite interested to actually hear about you as well is that you're all kind of interested in the kind of like the perspective of the audience and how you can kind of bring the audience in through these processes as well. So I have kind of 2 questions that relate to the perspective of audiences. The first question I wanted to ask, which is a little bit about kind of how we imagine AI as an audience or the public perception around it. So for me, a lot of the idea of the applications of artificial intelligence as a broad, like as a field, as a domain. Right now, the way that it's used and the way that it operates as a kind of as a tool of capital. It's there for monetization. It's there to improve processes. It's there to reduce labor. So it has very much kind of its foot kind of firmly planted into the field of like technological growth and kind of capital growth. So, but when we look then kind of like how do we understand kind of like AI as kind of together? And that's kind of where maybe the question around audience comes into play. So most of the narrative that we as kind of like, when you think about people who are not really, who don't kind of like encounter or think about kind of artificial intelligence in a very kind of day-to-day sense, a lot of the way that, or a lot of the narrative about artificial intelligence comes from science fiction and literature. And so, a lot of these things, they speak to this idea of like sentient machines or utopias and dystopias and things like that. And really my question here is, where is your practice located in relation to either one of those things? In the real world capitalist AI or in the sci-fi fantasy AI? And it's also perfectly okay to say neither.
I mean, I can't get away from AI in cinema because I'm using AI in cinema as a reference point. So it's hard for me to answer that one because, I mean, I guess I would put it in the sci-fi category in general, but at the same time, as a kind of antidote to the sci-fi positivism, while, I mean, just the sheer fact that I'm appropriating copyrighted material and repurposing it in this weird artistic context is a rejection of some of the axioms of capitalism, because I'm, appropriating the labor of others in some domains illegally. That's arguable, but that's definitely part of the work. You can't get away from the fact that I'm, taking some, creative work of others, but creative work in a context of value generation in terms of capitalism. So I would say both, neither, and maybe a little more of the AI one. I mean the science fiction one.
I would say that it's complicated. Part of the reason why it's complicated for me, like and I guess it's true for you too, but I have all of the things I'm creating with AI machine learning comes from my own experience going through my own experience of working with these systems, and my first goal in life was to be retired like my grandfather, but my other alternative job was to become an inventor and become someone who would become a scientist, computer scientist, working in AI. And I had actually the chance to study in the early 2000s in Yoshua Bengio's lab at University of Montreal. So I studied the neural networks before they became marketable. And then I left to become an artist, and I never regretted that choice. And I think that part of what I'm trying to do in my work is I'm always sort of trying to work with these capitalistic technologies and just turn them into something that does not have any market value. And something that interests me. And so the reason why I first got into this field was that I've been I've been obviously fascinated at first, like a lot of people go into AI by science fiction, and but I've always been just viscerally attached to seeing these things running in on a machine that can learn stuff, that can become, that can transform and just through their own perception learn something about the world. So I guess that I'm not nowadays thinking about making anything that is science fiction. I'm just thinking about bringing to people who are maybe just breaking people's biases about these technologies. So for example, when I show the robot installation, we have people who are passersby, and they think that we're trying to they think that we're there to do an advertisement. They're there that they're afraid. I've seen people attacking the robots, trying to. I had to jump a few times to save the robots in the water and stuff like that. Or then and then some people become that there's. I try to create a space for people to imagine something alternative about these systems. So I guess this is so in a way it's it is definitely anti-capitalistic. It is. I'm not seeking to necessarily to have people think about. I'm not necessarily thinking about science fiction. I'm thinking about what are other things we can do with these technologies, and how can the audience participate to that and get to maybe develop a different kind of feeling about technologies, that there's not something that's separated from us. This is just part of society, and that this is not something that necessarily needs to be imposed by other power structure, that it can actually become just part of, that it can resemble you, that the technology can fail, that technology can be imperfect, that it can be cute and curious and frustrating, and that this is something that is, just in the end, just helps us maybe articulate how we live together. So, anyway, yeah.
Yeah, I sort of feel the same way that Sofian does about that. I think the underlying critique that I try to make apparent in my work is just like, by using computational processes and machine learning and artificial intelligence stuff, people can come to understand, because I do try to make work that like shows the process that produced it on the surface as much as possible, because I think that's what makes both good art and good poetry. In doing that, I'm hoping to help people to better understand, like, oh, this is what the computer is capable of, and also that this is all the computer is capable of, right? Like, this is the extent of it, and this is also like, if an artist can do it, then I could do it too. Like, it doesn't go beyond, because artists, as we know, are like the least capable of the professions. But yeah, just like trying to show through the work, like, here's how these underlying systems work. I think that one of the jobs of poetry as a medium is to show like that language could be otherwise, that we could speak differently and use language in ways that are unexpected and have their own systems of meaning. And to the extent that language shapes reality and shapes politics, that's a very political message for poetry to be able to make. And so that's sort of what I'm trying to do with poetry that uses machine learning, is to say, like, talking could be otherwise. Here are all of the beautiful ways that we can make talking otherwise.
Yeah, I mean, I guess it's one of the things I really liked that Sofian just said in his talk was just about, like, how do we program machines and we don't really know how to, and we don't even know how to do things ourselves. I think that's kind of like quite inherent in terms of like the model of society that we live with, that it's kind of a little bit messy and it doesn't really work for everybody. So it's definitely kind of like apparent that, like, through calling attention to true procedures and through the processes by which kind of machines make decisions, that maybe it opens up a space of understanding that is not necessarily embedded in this kind of like science fiction space of like, oh, AI is, and it gets people to see it more as a tool rather than a piece of kind of like fantasy or magic. And I think that's a really important thing, especially when it's a very powerful piece of knowledge to give to an audience, because especially when you think about kind of like how technology is designed. So like this morning, I don't know if anybody saw, but like today Google removed the view image button, right click, so that now when you go on to Google searches and you look by view by image, you can no longer like view the image or like copy and paste it. And they do it as a very kind of deliberate strategy to kind of control kind of information, or to control kind of the circulation of information in a very particular type of way as well. So I guess the second question, before I kind of like open it up to the audience a little bit, is to maybe kind of think about, oh, where did I leave my notes? I guess it's just that it's a bit of a broad question, and I guess one of the things that I'm kind of interested in kind of knowing and understanding from your perspectives is like, what does AI as a tool offer for the interpretation of artworks? And how do you think that maybe it progresses our understanding of kind of like the way that art could potentially be as well? Because you're all using art in a very, like, in a creative domain. And I really like this idea of like creating stuff that's useless. I think that more artists should definitely do things that are useless rather than having to make something that has certain sort of like value, or it becomes this kind of like thing of pointy art, which is basically just pointing things out with your art. So I guess, yeah, that's my question, is like, how do you think audiences can be drawn into kind of new understandings of like where art can go, I guess? Is that too vague?
Well, I had a thought just before, which was also that we can use science fiction also as a tool to reflect on ourselves. And just to say it's this hypey future thing, I think is underestimating it a little bit. I think there is potential for thinking through science fiction as a way of reflecting on ourselves. And so I think of, and that's the reason why I chose science fiction films, is not just the depiction of AI, but My Machine is a way of thinking through our own processes, swallowing this other cultural machine of us understanding our own processes that is science fiction. In terms of the next one, I'm conceptualizing another project at this point, which is kind of taking the idea of the art market and twisting it in a way by making a very banal aesthetic generator that will just do whatever people pay attention to and is intentionally not very interesting.
So it's like a form of like machine zombie formalism?
Exactly. It's called the zombie formalist. Good catch. You got the reference there. So it's this weird, so that is intentionally unvaluable, but at the same time making fun of value and it's supposed to be ironic. And a lot of my work is actually a little bit ironic. Like the idea of making a machine dream was supposed to be ironic, but things
Maybe people took a little bit too literally.
well, it all of a sudden things changed, and the idea of a dream machine isn't so weird as it was when I started in 2009. So irony is something in there, and I think that kind of relates to your question of use, because you can use something and use it in a weird context in an ironic sense where you're not really using it seriously, you're just using it as a way of talking about some broader structure, and that's how I would be using it in that context.
One way that I'm trying to name the thing that I'm thinking about. I think a lot about there's a school of poets, the conceptual poets, who are sort of like led by Kenneth Goldsmith, who's like, you know, well known for making works of poetry that are like sort of about appropriation and scale, like taking somebody else's work and taking a lot of somebody else's work and then presenting it as like, you know, here's a total transcription of one issue of the New York Times or something like that. And he talks about, and he's written and spoken about this, he talks about the idea of him not wanting to have a readership, he wants to have a thinkership. In other words, that the work exists purely to be thought about as like, this is an artifact that I made that is literary, it consists of words, but it's not meant to be read. I'm the opposite of that, and I think that a lot of work that's computational or focused around procedure, and especially work in machine learning, tends to be about that overwhelmingness of scale, and that seems like a message that it's sort of like stuck on. That's like, oh, there's a lot of data. Look at just tons of data, so much data. Oh my God, what are we going to do with all of this data? Whereas what I'm trying to do is like I put a lot of effort into my poetry, even though it's unusual, to make it something that's readable and intimate and tries to like engage you from one moment to the next. And I think that's, for me, sort of the antidote to that is like, you know, machine learning does take a lot of data, but what if you're using that to make works that do feel like they're smaller and more intimate and are more expressive or something like that. Of course, I'm not always successful at making something that's engaging on a moment-to-moment basis, but that is the goal.
So in relationship to that question, I will bring up a kind of a radical, shocking idea is that Allison was talking earlier about computational creativity, which is this subfield of AI that tries to solve the problem of creativity by basically having trying to pass the Turing test in certain artistic domains. So what I think is that they will be successful, and to a certain extent. They will be successful in that they will be successful in trying to solve the Turing test. But for what I would say is the formal aspects of art. So, I mean, the first signs of this is in music. You already have companies that are now using machine learning to, you don't have to, if you want to have music composed for your commercial or your short movie or for your show, whatever, you can just hire this company and they'll have a program help you compose your scores. So, and there's been like 20 years of research at least done in that field. So, and it's ripe now for the taking. Now, this being said, this will come up with the formal aspects of music composition within a certain area of different genres, and I think you'll see that then coming to, like, all of the pop music being just created entirely by algorithms and maybe performed by artificial by robots, or like some of you might have heard of Hatsune Miku and other Vocaloids, so like holograms that are performing and people go and see their shows. And now it's like the last missing step is just that the whole process is being generated. I think, like, I don't see why. I think this is a low-hanging fruit and it's difficult, but I think that it's given the time, it will be sorted out, and eventually it will be also true for, like, generating visual arts. But that does not, we already know that this is already not interesting since Duchamp put the fountain in, like in the museum, and like since we like basically we're like, we have these people who are saying, yeah, we solved the problem of, like, generating good modern art, I guess, but like we're not as artists, we're not, it refers to what is still a public conception of what art is, and and for most people, art is like mainstream, well executed, formal novelty that changes every week, and I don't see what it's already industrialized, so I don't see what we're losing with having it be made by Google, aside from maybe some concentration of power in the hand of the companies that are already like. So I don't think it's a problem for arts, is what I'm saying, because because the fact remains that the kind of things that we're doing and that a number of other people are doing with these technologies is just not. This approach is not to try to it's just to really to use these technologies in strange ways and to open up these new potential. So I was thinking about, you were mentioning these cut-ups, and I don't know, I came to this conference thinking about Oulipo, this French movement, and I really like this. So Oulipo comes from ouvroir de littérature potentielle, which means opener of potential literature, and I really like this idea of, like, these technologies being openers of potentials, of new ways to imagine things. So
I was going to say that one of those contests in computational creativity, one of the past the Turing test contests, is there's a generate a sonnet in order to, like, try to make people think, like, people then have to pick, like, whether the sonnet is computer generated or human generated. And the thing for me is, like, okay, the people who are making entries to this contest, they're doing a lot of research, working with words, coming up with a system for putting those words in order, and then producing those words as an artifact. There's a word for a person who does that process. It's poet. Like, that is literally the work of a poet. And from that perspective, it's like, even though they might not think that they're poets, that's exactly what they're doing, right? And the same thing goes for like composing music, right? Like, even if that process is eventually automated, and to a large extent it is, even without like the process being fully, like even when we're using like software to compose music, we're taking the suggestions of the software, right? There's still people whose responsibility it is to bring about the system that puts the notes into order on the page. And I don't see, like, just from a purely like ontological whole perspective, how that person's work differs from that of a composer, right?
I agree, and I was going to talk about computer-aided creativity as opposed to computational creativity, and this idea that there is a system that could be a novelty generator that maybe is informed by a model of your own aesthetic, but is just there to provide suggestions or alternatives or other ways of thinking about what you're doing and not be autonomous. And then there's always this question of sure, there's companies that are generating music, but there's always this question of at what level of description is that autonomy applied? You could generate the notes, but not the music. You could generate the notes and the music. You could generate your own instruments that generate the music. You could generate, a song. You could generate an album. You could generate a business model. You could generate a marketing. Like, there's no, like, you can't autonomize everything because, again, we're always going to get back to somebody who's orchestrating these systems.
Yeah, I would say like second for second, even in like a perfectly generated piece of music that would trick anybody into thinking that it's not computer generated, there's more human choice going into that second than like any Mozart sonata.
And maybe a lot more human labor.
Actually, a ton more human labor.
But the promise is that by automating it, that eventually you'll just be able to patent the algorithm and then just fire everyone. That's a threat. And I think another threat, and because I'm kind of joking and saying that this is kind of good news for artists. I don't think it's entirely good news for artists. I think one of the bad news is that basically, so if you want to make a system that generates all kinds of genres of music, and this way you don't have to pay artists anymore, well, this system will actually have to be trained on music generated by humans, and we know that already, you're all aware that artists are not, most artists are not making a lot of money. They're living in really harsh conditions. They work really hard, and basically to have all of this production being stolen or appropriated by structures of power that are I think there is a problem there which is related to this replacement of labor by AI.
Well, but creative people are already exploited, right? Creative people are already exploited.
Yeah, but do we want them to be exploited more?
I guess that's true. Anyway.
Yeah.